Section 5.1, we are dealing with vectors. We are continuing dealing with forces, although Chapter 5 is now dealing with forces in two directions. And when we start to deal with forces in two directions, we have to bring angles into effect. So this is going to be very similar to the back of the worksheet, the Chapter 4 review worksheet you did, where maybe you had two forces pulling north and one force pulling east, and you had to counteract the forces. Now that's very simple because they all balance out. Here now we're going to have to actually figure out the angle. So when we talk about vectors in multiple directions, you're going to add them by adding vectors by placing tip to tail. And I'll kind of demonstrate that with in a couple of examples. You may need a protractor to get angles, and we really won't need a protractor, but you're going to mathematically solve to get angles, and you're going to do that using trigonometry. So when we take a look at trigonometry, I talked to all of you guys yesterday in class, or today in class, about whether or not you've done trigonometry, and you said you all have. So SOHCAHTOA is nothing new. SOHCAHTOA is nothing new for you. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So that is nothing new to you. Secondly, so you can add those to your equation cards. As we keep moving, here's something else that shouldn't be new to you. All right, the Pythagorean Theorem. Now, when you did the Pythagorean Theorem in 8th grade and you've continued to do it, you've just done c squared is equal to a squared plus b squared. In physics, we use r squared is equal to a squared plus b squared. R squared is the hypothesis. Now, why is it the hypotenuse, or why do we use r? R stands for the resultant. And the resultant is the combination of our two vectors. So that is why we use r instead of a. So you just see r is still the hypotenuse. We are trying to solve for the resultant. So Pythagorean Theorem should be nothing new for this equation. What we will have, though, is you've probably never had an equation if you could solve for r if you had an obtuse or acute triangle. So if you look at r here, law of sines, r divided by the sine of theta, and theta is our angle that we would get, is equal to a divided by the sine of a, which is equal to b divided by the sine of b, or law of cosines, which is r squared is equal to a squared plus b squared minus 2ab times the cosine of theta. We use the law of sines for an angle less than 90 degrees, and the law of cosines for something greater than 90 degrees. Now, one thing that is super, super important that I have to point out, and I will continue to write you in class about, is that if you are in pre-calc or calc, right, your calculator is in radians. Right? You need to make sure when you walk through the door into physics that you change your calculator to degrees. We are in the real world. We do not use radians in the real world. I don't say you're going to go out the door and take a direct 1.8 radian degree turn. No, you go out the door, it's a 90 degree turn. So we are in the real world. Sorry, Mr. Dosedahl, but we are using degrees, not radians. Now, if you get caught in the mishap of, I used it in radians, do I have to go back and solve everything? Well, not really, but just keep in fact 1 radian is approximately 57.3 degrees. So we continue to use degrees. We don't use radians, so just a reminder to change your calculator. So we have 5 equations here that are just the tip of the iceberg when it comes to figuring out forces in 2 or more directions. So what we have is we have a couple of examples. And nothing that you can't handle. So A, find the magnitude. When it asks for find the magnitude, you're trying to solve for how much force there is. That's what magnitude means. Magnitude is how much force is there. So we're solving for the force or the resultant. What is the magnitude or the sum? Right. So find the magnitude of the sum of a 15 kilometer displacement and a 25 kilometer displacement when the angle between them is 90 degrees. Well, remember earlier we did tip to tail. So I'm going to go right here. This is 15. Here's my tip. Here's my tail. I'm going to go up. Here's 25 kilometers for each. All right. I want to go through and I want to solve for r. Now remember, you've all done Pythagorean Theorem. This one should be nothing new. R squared is equal to a squared plus b squared. A in this case we'll take as 15 squared plus b squared, which is 25 squared. You get r squared is equal to, oh, I didn't write this down. I think it's 860. All right, you square root both sides. And since we are left with 2 sig figs, you technically could say 1 because the angle is 90 degrees and only is in one angle, but we will go 2. R is 29 kilometers. All right. Now that is a very simple Pythagorean theorem. That's something you've done before probably hundreds of times, so it should be nothing new for you to do. What might be different though is what if the angle between them is 135 degrees? So again, we draw it tip to tail. So we have 15, and then we're going to have 25, and we want to solve for r again. Well, remember going back to the last slide, if it is greater than 90 degrees, that's greater than 90 degrees, we're going to use the law of cosine. So the law of cosine is right here. So let's go ahead and plug this in. And when we do that, we get r squared is equal to a squared plus b squared minus 2ab cosine of theta. And again, theta just means angle. We go ahead and plug that in. 15 squared plus 25 squared minus 2 times 15 times 25 times the cosine of 135 degrees. That is all equal to r squared. I could sit here and plug this into my calculator, and you can try if you want, but all I'm going to do is I'm going to take the square root of both sides, the square root of this huge long number, and I end up figuring out that r, when we round to 2 sig figs, is 37 kilometers. Right. If you have questions with punching that into your calculator, or maybe you didn't exactly figure that out correctly, you can talk to me in class tomorrow and we'll make sure we get squared away on that. So we have 2 triangles. We have the angle between one is 90 degrees, Pythagorean theorem, something very simple that you've done before. And then we have the angle is greater than 90, so it's 135. We use the law of cosines. We solved. Fair enough. Now we add one more catch to this. This is a physics-typed Pythagorean theorem problem. Now, when we have component vectors, we're really just adding our vectors together. Stupid thing. All right. And all right. So we have our component vectors. We're going to break into x and y components. It's always, guys, it's always when we're doing this, it's always about x and y. We can solve for anything if we can break it into x and y. And also remember that just like you had equations for sine, cosine, and tangent, you can solve for the inverse of those, which is tangent to the -1, cosine to the -1, sine to the -1. And the tangent theta is equal to tangent to the -1 of ry divided by rx. And y is in the y direction and x is in the x direction. Now you may have taken that as opposite divided by adjacent when you do a triangle. That's fine. That's what we did in trig. In physics, we're breaking it down into more y and x graphical functions. So if we look at our example, a GPS receiver spelled wrong, should be EIVER, indicates your home is 15 kilometers and 40 degrees north of west. But the only path is through the woods that leads directly north. If you follow the path for 5 kilometers before it opens into a field, how far and what direction do you have to walk to get home? First things first that we have to discuss, that's going to come into play here, is our sense of direction, how we write directions down in physics. If we have just a general compass, we have west, east, north, south. There are two ways that you can write every direction. All right, and how you would do that is this. I could have, let's say I have it this way, 40 degrees. Let's go this way. Let's go 30 degrees right here. Let's say this is 30 degrees. Right? There are two ways I can write this direction. First things, I could write it as this. This is 30 degrees, and the arrow means I am north of west. So the green line that I just drew, not the arrow, the line, is 30 degrees north of west, since I am north of west. Fair enough? I'm north of west. Now, I could also write that angle as, not 50, 60, sorry. Should be 60 degrees. I can write that as 60 degrees on the other side. However, this is 60 degrees now, but it is 60 degrees west of north. All right, where the other one is 30 degrees north of west. And there is a difference between those, and you will see that come up. So we will work on that in class when we go over the problems, but it is very important that you have the right direction. There is a difference between west of north and north of west, because 60 degrees and 30 degrees will vary in an equation. So make sure you're kind of drawing it right, and when you're finally summarizing your problem, you're using the correct direction. So with that said, let's go ahead and start this problem. Well, first things first, all right, we need to figure out how far away we are from home, all right, before we even start walking. So a GPS receiver indicates your home is 15 kilometers and 40 degrees north of west. So I'm going to go ahead and I'm going to draw my triangle. Here's my origin. I'm north of west. So I'm going to draw it this way. This is 15 kilometers. And I do not know my x value and I do not know my y value. Well, before we even continue, I want to figure out my y value and I want to figure out my x value, understanding that I am 40 degrees. So how am I going to do that? Well, we're going to use a little bit of trigonometry. So when we're solving for the y, or the opposite, remember, all right, we're going to use sine. So sine of theta is equal to opposite over hypotenuse, which is equal to the sine of 40 degrees, which is opposite over 15. We're going to multiply those together, and when we do that, we figure out that this is 9.64 kilometers. Now, that's not my final answer, so I'm not worried about sig figs, but I have 5.0, 15.0, and 40.0, so my answer should be in 3 sig figs. I'm going to go ahead and do the same thing. I want to solve for my adjacent, or x value. Well, the cosine of theta is equal to adjacent over hypotenuse. When you do that, and we go ahead and plug that in, the cosine of 40 degrees is equal to adjacent over 15. You're going to multiply those together, and when you figure that out, you're going to get 11.49 as our triangle. So now we have discovered every side of our triangle. And our base triangle looks like 15 here, 9.64, and 11.49. But the question is asking, I have to walk 5 kilometers north before I get home, or before I can walk through the field. I have to walk straight north for 5 miles. Well, if I'm walking 5 miles north, all right, I'm going to eliminate a good chunk out of this triangle, so we're going to subtract 5, and our new triangle is going to look like this. We're going to have it's 4.64. because we subtracted 5 miles, and still 11.49. Now, the question is asking still, right? The question is asking, how far of a walk is it once I get through the woods and I have to walk through the field? Well, that's very simple. We're going to solve for r. All right. We have both sides, so r squared is equal to a squared plus b squared. That's equal to 4.64 squared plus 11.49 squared. If I take the square root of that whole value with 3 sig figs, I figure out that r ends up being 12.3 kilometers. All right? So I end up figuring out that r is 12.3 kilometers. But I'm not done quite yet. I need to figure out the angle at which I am walking still. So how am I going to do that? Well, remember, theta is equal to the tangent -1 of ry over rx. Well, we go ahead and plug that in. Theta is equal to the tangent -1 of ry, which in this case is 4.64, divided by rx, which is 11.49, and I end up getting that theta, using 3 sig figs, is 21.3 degrees. What's important to note is, again, direction comes into play. We started north of west. We're still going to end north of west. Our angle is just slightly different, so we are going to go 21.3 degrees north of west. Now, when we talk about component vectors, if I were to write my final answer, since vectors have a unit and direction, my final answer would be 12.3 kilometers at 21.3 degrees north of west. That would be my final answer. So you can see this starts to get slightly more complicated when we start talking about vectors and two vectors at the same time. Direction is key. You always have to make sure it's north of west, west of north. There is a difference between the two. You're using a little bit of Pythagorean Theorem, which we've used. Other than that, if you have questions, we can go over it with the problems in class tomorrow.